In this video, we'll continue our talk about linear inequalities, and we'll move on to compound linear inequalities. As a refresher, a one-variable linear inequality is simply an inequality that has one variable where the highest power of that variable is 1. We have 3 different ways we can visualize the solution of these inequalities: set notation, graph, and interval notation. So what's a compound inequality? A compound inequality is simply an inequality that's more than one inequality. We have some examples here. If we have 5 is less than 2x minus 3, which is less than 10. We could also use the words or and, where 2x is less than 7 or 9 is greater than or equal to x minus 2. And then we also have x is less than or equal to 7 and 9 is greater than or equal to x. Now the solutions depend on the type of compound inequality. If it's an and, it's going to be an overlap of their solutions, while or is going to be the combination, or essentially the union of it. If you remember from set notation, this is essentially going to be an intersection, while the or is going to be a union. That's why it's possible to have no solution if there's no overlap in an and. And it could be all real numbers if there is overlap in an or. What we'll do now is we'll practice one and one or inequality. Let's suppose we have the and inequality of 14 greater than negative 2 times the quantity of x plus 7, which is greater than 9. Now, because we have the variable in the middle, and we have 2 inequalities on the outside, we are going to do the operations on both sides of the inequalities. In other words, if we have 14 greater than negative 2 times the quantity of x plus 7 greater than 9, we will do any operation from the middle to both the 14, this end, and the 9 on this end. If we start by dividing by negative 2, we'll get the new inequality of negative 7 is less than x plus 7, which is less than negative 4.5. Reminder, when we are dividing by a negative number, we need to change the orientation of the inequality. Now I'll go ahead and subtract 7 on both sides. Minus 7, minus 7, minus 7. So we're going to get negative 14 is less than x, which is less than negative 11.5. Now we want to write the 3 different types of notation. Set notation says that my solution of x is an element of R such that negative 14 is less than x, which is less than a negative, oh no, there, 1.5. Oh dear, it's terrible. Let's try again. There. So S is equal to the set of x, an element of the real numbers, such that negative 14 is less than x, which is less than negative 11.5. In interval notation, it is simply the interval of negative 14 to negative 11.5. Remember that we always go from the smallest number to the largest number, the lower bound and the upper bound. Then finally, we want to find that graph. I'm going to have a number line, and I'm going to put negative 14 here, and then I'll do 13, 12, 11. So 11.5 is somewhere around in here. Now, since they're both open, we can tell that by the parentheses. We're going to have open circles at the 14 and at the negative 11.5. Now, since we want the numbers in between, and we know that because we have the interval notation where this is the lower bound, this is the upper bound. And then we also have the set notation, which has the inequality. We're going to shade in everything in between. And there we go. Now let's look at an OR inequality. Here we have two different inequalities separated by OR. That means that at least one of them has to be true. Again, a union. So I'm going to solve them simultaneously but separately. So we're going to get, let's see, if I subtract 4, we're going to get 8 is greater than or equal to 5x, or x is less than 4 ninths. So 8/5 is greater than or equal to x, or x is less than 4 ninths. Okay. First thing we're going to do is we're going to do set notation. That one's the easiest one to write down. Because S is simply the set of x that's an element of R such that x is less than 4 ninths, or 8/5 is greater than or equal to x. Now before I do interval notation, I'm actually going to do the graph first. Okay. Now they're both greater than 0 because they're both positive, so I'm going to put 0 over here. Now I want to figure out what the approximations are. 4 ninths is 0.4 repeating. So this is 0.4 repeating. And this one is, let's see, 5 goes into 5, there's 3 left, so this is 1.6. So I'm going to estimate 0.4 here, which means 1's here. And then if 2's here, I'm going to estimate here as 1.6. Now if we look at each individual inequality, we have x is less than 4 ninths, which means I have this, and I'm going less, where 0.4 is open, 0.4 repeating is open. And then I have over here is I have 1.6 here, but it's included. So here it says x is less than 4 ninths and 8/5 is greater than or equal to x. Now this one right here also means that x is less than or equal to 8/5. So I'm going to actually drive this way. Now the solution is the overlap of these two. Looking at this graph now, I could actually change my set notation to actually only include this. Now why? Because the second solution, that's different, let's use this yellow, because this solution is actually encompassing or inside this one as well. So don't need to worry about that. So then my interval notation is simply negative infinity to 1.6, which is included. Now, it's okay that in this section of the solution that it does not solve the second one. It won't solve this one. But that's okay because it's an OR. If it was an AND, then it would not, and we'd actually include only the second half, or this side. We'll do more practice in class with compound inequalities.